Now we are going to discuss about the properties of Laplace transform. These properties will help you to solve Laplace problems, so you need to be thorough with this. First one is linear properties, that is L of a1 of f1 of t plus a2 into f2 of t can be written as a1 into Laplace of f1 of t plus a2 into Laplace of f of t. Then another one is shifting property. We know that Laplace transform of f of t is f of s. Then L of e raised to at into f of t can be written as f into s minus a. That can be called as shifting property. Then third one is scaling property. Here Laplace transform of f of t is f of s. Then Laplace transform of f of at can be written as 1 by a into f of s by a. Another one is division property. Here Laplace transform of 1 by t into f of t can be written as integral s to infinity f of s ds. The fifth one is transform of integral. Here Laplace transform of integral 0 to t f of t dt can be written as 1 by s f of s. Then multiplication property, that is L of t raised to n f of t equal to minus 1 raised to n d raised to n by ds whole raised to n into f of s. Then last one is Laplace transform of derivative. Here the Laplace transform of f of t equal to f of s. Then Laplace transform of t raised to n f of t, that is n is the nth derivative represent small n, that is s raised to n. Laplace transform of f of t minus s raised to n minus 1, f of 0 minus s raised to n minus 2, f dash of 0 minus s raised to n minus 3, f double dash 0, etc. And these are the properties of the Laplace transform, so you need to be thorough with this. Now we have to solve some problems using these properties. The first one is find the Laplace transform of sine squared t. We know that by trigonometric function sine squared t can be written as 1 minus cos 2t by 2. That is by using linear property we can written as Laplace transform of 1 minus cos 2t by 2 can be written as Laplace transform of half minus L of cos 2t by 2. And by taking half outside we can get that half into Laplace transform of 1 minus half into Laplace transform of cos 2t. We know that L of 1 can be written as 1 by s, and L of cos 2t, that is cos 80, can be written as s by s squared plus a squared. Here a is the 2, that is s by s squared plus 2 squared, that is s by s squared plus 4. By putting these values in equation 1 can be written as half into 1 by s minus half into s by s squared plus 4. So by simplifying last we got that 2 by s into s squared plus 4, that is half 1 by 2s minus s by 2 into s squared plus 4. By taking half outside, 1 by s minus s by s squared plus 4, that can be written as half into s squared plus 4 minus s squared by s into s squared plus 4. Then cancelling 2, as we get that 2 by s into s squared plus 4. That is, the question is find the Laplace transform of L of sine 2t equal to 2 by s into s squared plus 4. Now we move to another problem. Find the Laplace transform of cos t into cos 2t. We know that 2 cos a cos b equal to cos a plus b plus cos a minus b. So cos a into cos b can be written as half into cos a plus b plus cos a minus b. Here cos t into cos 2t can be written as half into cos 3t. Here a equal to t and b equal to 2t, and cos 3t plus cos of minus t. that is Laplace transform of cos t into cos 2t equal to half into Laplace of cos 3t plus half into cos t. We know that cos minus theta equal to cos theta, that is cos minus t equal to cos t. And we written as Laplace of cos 3t can be s by s squared plus 9 and cos t can be written as s by s squared plus 1. So finally we get that half into s by s squared plus 9 plus s by s squared plus 1. Here the answer of the Laplace transform of cos t into cos 2t. The another one is find if Laplace transform of sin t equal to 1 by s squared plus 1 equal to f of s, then find the Laplace transform of sin 6t. Here we using the property is scaling property. If Laplace transform of f of t equal to f of s, then L of f of a t equal to 1 by a into f of s by a. So Laplace transform of sin 6t can be written as 1 by a into f of s by a. Here a equal to 6, that is 1 by 6 into f of s by 6. Here we know that Laplace transform of f of t equal to f of s. So given that L of sin t equal to 1 by s squared plus 1, that can be called as f of s. So f of s by 6 can be written as 1 by s by 6 whole squared plus 1. So finally we get that 1 by 6 into 36 by s squared plus 36. So another problem is Laplace transform of e raised to bt into sin a t. Here we use the property shifting property, that is L of e raised to at into f of t can be written as f of s minus a. Here f of t equal to sin at, that is L of sin at, we already know that a by s squared plus a squared equal to f of s. So L of e raised to bt into sin at can be written as f of s minus b. We know that f of s equal to a by s squared plus a squared. So f of s minus b can be written as a by s minus b whole squared plus a squared. Find the Laplace transform of t raised to half. We know that Laplace transform of t raised to n is equal to gamma n plus 1 by s raised to n plus 1 or n factorial by s raised to n plus 1. Here n equal to half, that is Laplace transform of t raised to half can be written as gamma half plus 1 by s raised to half plus 1. We know that half plus 1 equal to 3 by 2, that is gamma 3 by 2 by s raised to 3 by 2. By gamma function we studied that gamma 3 by 2 can be written as gamma pi root pi by 2 or half into root pi. So by substituting these values we get Laplace of t raised to half equal to half into root pi by s raised to 3 by 2, that is root pi by 2 into s raised to 3 by 2. So this is the answer of the Laplace transform of t raised to half. The another question is find the Laplace transform of t into e raised to t. So we know that f of t equal to e raised to t, then Laplace transform of f of t equal to Laplace transform of e raised to t equal to 1 by s minus 1 equal to f of s. Here we use the multiplication property, that is L of t raised to n into f of t equal to minus 1 raised to n d raised to n by ds all raised to n f of s. So here find the Laplace transform of t into f of t. Here the power n equal to 1, so minus 1 into d by ds into f of s. We found that f of s equal to 1 by s minus 1. So by substituting minus 1 into d by ds of 1 by s minus 1. By taking the derivative with respect to s, we get that minus 1 into minus 1 by s minus 1 whole square. Minus into minus positives, that is 1 by s minus 1 whole squared. So by this we have completed the topics regarding with Laplace transform in our syllabus. So you should go through this online class section and prepare your own notes and also do the homework section in your notebook which you need to submit when the class reopens, and I will be consider this as an assignment for your internal mark. And thank you.